little more work on function notation. Consider the function 10x minus 3. If you want to think of that as y equals 10x minus 3, that is perfectly fine. And now they say, now we're working backwards. They say, we took some value of x, we're not telling you what it is, and we did 10x minus 3 to it, and it came out to 47. So read this as, we took function f, we plugged a number into it, and we're not telling you what it is, and 47 came out. And now they say, figure out what our x was. So 10x minus 3 equals 47. How do you solve this for x? You want to get rid of the negative 3, and you can do that by adding 3 to each side. That gets you 10x equals 50. And now we want x by itself, but it's multiplied by 10. The way to get rid of the opposite of multiplying by 10 is dividing by 10. Do that on both sides, and you get x must have been 5. If you want to check this, you can actually take it back to the original function and try it out. If x is 5, then they would have done 10 times 5 minus 3, which would be 50 minus 3, which would be, yep, 47. So it worked. This must have been the x they started with. And now they do it again with a different number. They're saying, we took function f, we plugged an x into this, and we're not telling you what it is. And what came out was minus 23. Add 3 to each side, and you get 10x equals negative 20. Divide both sides by 10, and you find the x they started with must have been negative 2. So if we give you something like f of 2 equals, it means plug this 2 into the function and tell us what comes out. If we say f of x equals some number, we're saying, here's what came out at the end. You work backwards and figure out what x we must have begun with.